Hello everyone, I am Pavankumar Patil, working as Assistant Professor in Department of Electrical Engineering, SITCOE. So today in this session we are going to discuss about the AC voltage controllers in power electronics. Okay? And that particularly we'll be discussing about the principle of phase control of single phase circuits and phase control of three phase circuits. Okay? So before going for particular what is phase control, let us see what is AC voltage controller. We have come across many AC voltage controllers till now. In that particularly, a transformer is also AC voltage controller. What it does, it steps up or steps down the voltage. So that can also be considered as a AC voltage controller. But in that, we are going to vary the amplitude of the output voltage or reduce the amplitude of output voltage. Okay? But we are not going to do anything else with respect to the wave shape. Wave shape is going to remain the same. But what if the wave shape has to be changed? In that case, the solution is the phase control. First, we'll discuss about the principle of phase control. As you can see in the diagram, we have a phase control circuit over here. Here we have the supply and we have the load, and that is provided with the thyristor. That is fed with the thyristor, and it is connected in anti-parallel with the diode. It means to say, in the positive half cycle, whenever the voltage is positive, then the current will flow from here to here, the positive current, and in the negative cycle, the voltage will be negative, so that again it has to flow through the diode to back to this one, back to the source. Okay? So let us see this. It means to say, in the positive half cycle, the waveform is controllable. In the negative half cycle, the waveform is uncontrollable. Means we will be getting continuous negative voltages. No problem with that. Okay? But when it comes to the positive waveform, there we can control the voltage, as we have seen in the few lectures, that by providing an angle of alpha, that is, in the positive half cycle, T1 will be forward biased, but whenever this gate supply is given, only in that case it is going to turn on. So that it means to say that we can control the waveform from 0 to 180 degrees. Means as we vary the alpha, the output voltage or output wave shape is going to change. ठीक है? It means यहाँ पे हम क्या कर रहे हैं? We are giving AC as an input, and here in transformer, if it is a transformer, we are going to step up the voltage or step down the voltage. But here we are not going to do that. The wave shape is going to be the same only, but only thing is we are going to remove some part of the wave shape, like we did over here. Okay? So in this way, we are going to operate or we are going to control the phase of any circuit. Okay? So let us go for understanding how can we do that in a single phase circuit. So obviously, in a single phase circuit, if you want to do that, we have to have two anti-parallel connected thyristors. In the previous case, we had only one thyristor, that was only for the positive half cycle. Here we can do the same thing for the negative half cycle also. So let us have input AC waveform. Here for the positive half cycle, I am giving the firing angle at this instant, so that the waveform will start from here and end up to the end of 180 degrees. And in the negative half cycle, again, I am not going to turn on at the 0th instant, I will be turning it on this instant. So because of that, the waveform is going to start at this instant. Means I am going to control the both positive and the negative wave shapes. So because of that, I will be getting this kind of output voltage. What about the current? If it is as it is a resistive circuit, I am having the current waveform as same as that of the voltage waveform. Okay? And what is the voltage across the thyristors? What is the voltage means across thyristors means how much voltages the thyristor is blocking. Okay? So we consider that whenever the thyristor is on, in that case the voltage across the thyristor is 0. In remaining waveforms, when the thyristor is off, in that case it is going to oppose the entire voltage which is appeared across that one. So in the positive half cycle, what is happening? The thyristor T1 has to block initially. Whenever it is not turned on, it has to block the supply voltage. What was the supply voltage? It is going to block up to it is going to turn on. Once it is turned on, the voltage across the thyristor is 0. Okay? Again, in the negative half cycle, or you can say in the for thyristor T2, we are going to do the same thing. But what is this negative and what is this positive in this case? Here, as a thyristor is anti-parallel connection, whenever there is a positive half cycle, T1 is blocking the positive voltage, at the same time T2 is blocking the negative voltage. Okay? Means what is the voltage which is positive for T1, it is negative for T2. So because of that, we can see the wave shapes of that one. Both are opposite to each other. So draw one waveform, draw the opposite of that. That is nothing but the thyristor T2. Okay? And what about this one? What about this instant? Here what is happening? The other thyristor is on. Because of that, voltage across this terminal is 0. So it is parallel to this terminal. So voltage across this also is 0. This is okay? This is about single phase control. Now let us go for three phase control. Here we are going to do nothing. So what are we doing here is the same waveform. There we have done it for the just a minute. There we have done it for the one phase. Here we are going to do it for the other two phases. That's it. But the only difference is we are going to do it with a phase difference of 120 degrees. Why? Because it is a three-phase circuit. So this waveform shows for the star connected load, and this circuit shows for the star connected load, and this shows for the delta connected load. As you can see, the load is delta connected here, the load is star connected here. But in both the cycles, we are going to do the same thing. We are going to control the phase of each phases, and we are going to displace phase A and phase B by 120 degrees, phase B and phase C by 120 degrees. Okay? How can you do that? Just by controlling the thyristor firing angles. That's it. Okay? So how many thyristors are there? So total there are 6 thyristors, and we are going to control which voltage, either line voltage or phase voltage. We can control both of them. I have shown both the voltages over here. So this indicates the line voltages, that is EA, EAB, EBC, ECA and EAB line voltages, and these are the phase voltages EAN, EBN, ECN. Okay? So the thyristor T1 can be turned on by IG1, T3 by IG3, T5 by IG5, T2 IG2. Likewise, we are going to turn them on, and this particularly indicates in which order they are going to be turned on. Okay? By seeing this, the gate pulse is given for some particular amount of time. So whenever a phase is more than any other phases, maybe it is line voltage or a phase voltage, if it is more than any other phases, we can turn it on by providing particular gate pulses. Okay? So the first waveform shows it for the 60 degree operation, and the second waveform shows the same thing for the 120 degree operation. So what is the difference? In 60 degrees, we are going to have more amount of output voltage for positive and negative, and here we are going to have less amount of output voltage for the positive and negative cycles. Okay? And as I told you, this 6 1 1 2 2 3 3 4 4 5 5 6 indicates the sequence in which they are going to be operated. So whenever if you want zero output voltage, what has to be done? Don't give the firing pulses. The next waveform, when it becomes 0, you are not going to turn on the next thyristor, so that output voltage is 0. Then again, when it comes to the next negative waveform, turn on the respective thyristors. So how can we get the negative waveform? Negative waveform can be got, for example, see here. One minute. Just a minute, sorry. Just a minute. Let us go for this eraser. Fine. Okay. So if it is a positive waveform, VAB, what is the negative waveform of that? VAB, it is the positive waveform. What is the negative voltage waveform is that? VBA, which is exactly 180 degree opposite to that. Okay? So whenever you want positive voltage, we are going to turn on whenever it is at VAB, the respective thyristors we are going to turn on. Whenever I want the negative voltages, then I am going to turn on VBA at the respective thyristors. Respective thyristors means here if I want a positive voltage, I am going to turn on T1, T3, T5s. If I want negative voltages, I am going to turn on T4, T6 and T2s. In this way, by triggering, we can get, or you can say, we can control the phase of the three phase circuits. Okay? Thank you.